So today we're going to focus on how the calculator finds the least squares regression line, which is the best regression line. And we're also going to talk about residuals. All right. So, like I said, we're going to talk about residuals. What is a residual? Anybody heard that word before? Have an idea? What? No,
Leftover.
leftover. That's what it means. So we're looking at the leftovers when we're talking about residuals. We do have to do it in a certain order, subtraction, so that we always are working with the same leftovers. So it's the difference between the observed y and your predicted y. Let's see, I can put observed there. The observed is just our regular y, and the predicted is the y hat. So, I write out the word residual when I write the formula. Let's see, I want to do it in a different color. I have seen it where they just write resid and they don't put the UAL. So residuals are found by taking your y minus your y hat. And like I said, sometimes they just put resid for residual. So in the warm-up, you guys found the regression line, the line of best fit, which Shelley told us was price hat is equal to 38,257.14 minus 0.16 times the number of miles driven. So yesterday we talked about how it's important that we use our calculators so we all end up with the same regression line. Well, there is a certain reason that the calculator picks this regression line. And so we're going to talk about that today and look at how they actually figure that out. So the least squares regression line of y on x is the line that makes the sum of the squares of the residuals as small as possible. Now it sounds really complicated, but I'm going to break it down for you. The sum of the squares of the residuals. So when the calculator is finding your equation, the y hat equals a plus bx, slope, which remember is b, the one next to x, is found by taking your r value and multiplying it by the standard deviation of your y divided by the standard deviation of your x. And yes, you will need to know this formula for your test. Weirdly, it is not a formula on the AP formula sheet, so it is one you have to memorize.
Wait, standard deviation of y over standard deviation?
Mm-hmm. And I'll show you an example type problem in a minute. Say that again? Yeah.
What's SY and SX?
standard deviation of the y variable, standard deviation of the x variable, and then r is your correlation coefficient. And then the y-intercept, which when we're in this form is your a, is found by taking your average y minus your slope times your average x. So you have to find slope to be able to find the y-intercept. And I don't know if you're one of those people that putting a star next to it's going to help you remember. I promise I will have a question about this on the test. The AP exam usually does too. Yes?
What does LSRL stand for?
Least squares regression line. Put it right here. Because the regression line the calculator gives you makes the sum of the squares of the residuals as small as possible. So we're making the least of the squares. That's how they abbreviate it. Any other questions? So the formula for slope tells us that a change in one standard deviation in x corresponds to a change of blank standard deviations in y. Anybody know what the change in the standard deviations in y is? It's in the formula.
I think what is standard deviation of
You put it in your calculator and you do 1 bar stats. I'm going to show an example in a minute. Nobody? R. It is R. So one standard deviation, one change in one standard deviation in x corresponds to R. Change it. I'm going to start over. If we change by one standard deviation in x, then we're going to have a change of r for the standard deviations in y. Because in theory, we can rewrite this as, because if this r is over a 1, which it is, we can rewrite it as r times the standard deviation of y over the standard deviation of x. So a change in 1 on our standard deviation of x corresponds to r. So now, back to that GPA, ACT data. I know you guys are probably tired of it, but we're going to keep working with it. And we're going to come up with our LSRL, the least squares regression line, by hand. And this is what I mean they'll put on the AP exam, the tech question I would put on the test next week, is I'll give you data and I'll say, okay, come up with your least squares regression line by hand. To do that, we need to find some information first so that we can use these formulas I just talked about up here. So to find our slope, we need to find our r value. We need to find our standard deviation in y and our standard deviation in x. To help us find our y-intercept, we need to know the average y value and the average x value. As a reminder, which one is x and which one is y? Say it louder for me. GPA is our x variable and ACT is the y. So I would, if you don't have it still in there, I would put GPA in list 1, ACT in list 2, and then you should know how to find R. You should know how to find your average and your standard deviation for each list. So I'm going to give you a minute to work through that. Hopefully remind yourself how it's done. Be nice to the calculator. Yep, make a list. You're not. Okay, you got your R. Now you got my zero.
What'd you get?
No. Standard deviation.
Wait, don't I do like
Oh, no, for R?
second?
Okay, I haven't done it yet.
Well, what did you get?
One bar stats.
I get R again.
Oh, I thought it was 2 bar.
No. We want to know the average and the standard deviation for each list individually. We don't do 2 bar stats until
Wait, what else?
Separately though.
Just
your
have
average.
you been?
Yeah, yeah. Yeah.
Wait, so how do you do this? How do you enter?
Second.
When did they start from the or is that after?
And even though it says S and X, it's actually your X and Y.
What'd you get?
That's the Y. Even though it says X, you know.
Oh, I know what you're talking about.
Yeah.
my favorite is
Mine are stupid.
How do you find your R again?
That's
what?
Oh, it says
Yeah.
Not that.
Wait. This is actually 4.86, right? Yeah, we just switched our Y and X here. S and Y. I put the X first on here. The X is yeah. I'm talking about the order should be from there.
I don't know how to find
Is it still going? Even though it's with
Oh, wait.
the order should be
Oh my gosh, how dare you? Yes, right. Open them up there. Put them in the order.
Yeah, we make a list.
All right, Maddie's
Make
gonna
two
put the
lists,
answers
or one for GPA, one for ACT.
on the board
And
for us.
That's what the line is on standard deviation.
Yes. Well, we're down to calculate. I went, well, let me rephrase that. I went to 2 on my standard deviation Y, but I went to 0.955. So 2/3. They're really not.
Oh, I got 4.81.
Oh, one rounded.
I got 80. Oh, you had like, but I placed it right. Sorry.
I don't find this a line as like hard.
Oh, it's dashed right there.
All right. Is it not acceptable?
It's 2 bar stops.
Except for, you have, you have the calculator.
C.
Yeah,
What?
these are your slides.
Oh.
Because you're working with the ACT.
Okay.
So she has Y average is 0.4. So you got it right, just know that it says X and you have Y. Okay? All right. So now that we have all our information, we're gonna use the formulas to find our slope and our y-intercept. So to find slope, you take your r and you're gonna multiply it by the standard deviation of y divided by the standard deviation of x. So our R is 0.955, and we're going to multiply by the standard deviation of y, 4.82, divided by the standard deviation of x, which is 0.4. So 4.82 divided by 0.4 times 0.955. So I get 11.50775. Now, I have seen a few of you, if it's that many decimals, you keep them, that's fine, I don't care. I usually round it too. Although Michelle did ask a good question. She said, how many decimals? And I was like, oh, 2. And then even though Maddie wrote this on my paper, I wrote 0.955. So I go to 2 or 3. I don't know. Depends. I think here I went to 3 because there was no number in front, and here I went to 2. 2 or 3 decimals is a good spot. So I'm going to round to 2, and I'm going to say that we have 11.51. Now that I have my B and I have my y average and my x average, I can find A, my y-intercept. So A comes from the y average minus your slope times the x average. So the y average is 0.4, and I'm going to subtract 11.51 times 3.4. So I get negative 15.134. So again, I'm just going to go to 2, so negative 15.13. Nate?
So on like the lumbar stat, what's the difference between S of X and lowercase sigma of X?
What?
S of x is the one that we use because the sigma of x, it has to do with the population. It's a slightly different formula. So standard deviation, usually we do n-1, which is degrees freedom. The sigma does not use the degrees freedom, it uses n.
Okay.
Okay.
So we use
That would be in a much higher statistics. We don't ever use sigma x in this class.
okay.
Are we good?
Yeah.
All right, so we have our slope, we have our y-intercept, and we can put our formula. So our least squared regression line is y hat equals, we put the y-intercept first, so negative 15.13 plus 11.51 times x. Anybody remember what the calculator gave us yesterday? Because you weren't here.
Was it?
It was almost the same thing. So yesterday, if you remember when I had you find the regression line using the calculator for the ACT GPA data, it gave us y hat is equal to negative 15.1 plus 11.5 times x. So we are really close. Our problem is that we did do, like on the standard deviation of y, we did do some rounding. The calculator doesn't have to. And on the r, we also rounded. And the calculator wouldn't, so theirs is going to be more exact than ours. But you can see we're pretty darn close. Now, we're going to verify that x bar comma y bar is on our least squared regression line, which means we're just going to plug these values in for x and y in our equation and make sure we get a true statement. I have seen this question show up multiple times as multiple choice on the AP exam. Just show that x bar and y bar is on your least squared regression line, or it'll say something like, which of the following points shows up on your least squared regression line? And that point does. Every time, no matter what your least squared regression line is, x bar comma y bar is on it. So our y bar, the y average is 24, so I'm going to put that in for y. And then I'm going to put 3.4, which is my x bar, in for x. And then I'm just going to show that hopefully this right-hand side is going to give me 24. It may not be exact because I did some rounding, but it should be pretty darn close. So 11.51 times 3.4, and then I'm going to add a negative 15.13. So I get 24.004. And that was my rounding and getting rid of that 4 right there. So we do end up with the x average comma y average on our least squared regression line. And yes, it will show up on my test, probably on the AP test. Like I said, for some reason they really love the linear regression on the AP exam. Can I flip? Yes. Great. All right, so now we're going to focus on residuals. And I'm not sure I liked how I formatted this. I think I should have done a table, but we're going to work through it. So, residuals, remember, come from taking the observed minus the predicted. So we have to find all the predicted y values for our GPAs. So I put the question, what's the predicted value for this GPA? We're going to fill in that column. The actual ACT data, which is all of these values here, and then we're going to take the observed minus the actual to get our residual. So I'm going to do the first one with you, and then I'm going to let you fill it in. But I'm sorry, after looking at it, I probably should have done a table. So to find our predicted, we're going to use our least squared regression line, which is y hat is equal to negative 15.1 plus 11.5x. And for the residuals, I'm using the one the calculator gives. Mine had a few extra decimals, but that was because of rounding. So in this column here, this is going to be all my y hats. So I'm going to find the predicted ACT score for a GPA of 3.0. So I'm going to put 3 in for x and see what I get. 11.5 times 3, and then I'm going to add negative 15.1. So I get 19.4. So that's the predicted ACT score. Everybody good with how I got 19.4? Mm-hmm. Then the actual ACT score, which is our Y's, back here if I flip over, this kid with the 3.0 had a 19. Residuals are your actual minus the predicted. So I would take 19 minus 19.4, which would give me negative 0.4 for the residual. Everybody good with how I filled in those 3 things? Negative 0.4, yes. You guys are going to find all the predicted. I'll put the actuals in right here so you don't have to flip back and forth. And then find the residuals for the remaining 5, please. So I put all the actuals on the board for you so you don't have to flip back and forth. easy equation.
So I was trying 19, or I was going.
That's our
There's
actual
exact
data. It's like saying Trey has
I got the
GPA 3.1, Trey 2, and then Sam had a GPA, or GPA 3.1.
I finished.
Let me see.
Two separate papers.
What you got it, Rose?
Kind of.
That makes
Sorry, it just needed two names.
I'm so confused now. One, you rounded.
Yeah, I did.
That's
Wait,
why they're
this one?
Oh, yeah.
That was just from the.
That's why I guess it's in
the table over here. I wrote them down.
Are you supposed to? Yeah. No, I want to ask her.
Oh.
Okay.
Look at the table for your life.
His answer, so he rounded different than his current answers on this, right? They're so ridiculous, right? Even if we round
Well, I don't know how you got negative 1 half.
26 minus
So,
26.
Oh, yeah. I suppose.
The normal.
it's because he rounded differently.
Oh, right, 19 minus
It's like,
26.
I don't know. It
Did
was
I do it
only
right?
2 decimals.
2 decimals.
Just leave it at 2
I
decimals.
think,
It just said 2 or 3 and
Oh,
you
it's
rounded to 1.
did I do it right? Cause like, that's
I got it from the
It
bottom.
just looks, I just followed what you did, 19.4. So what does
Well, that was 19.4.
Oh,
I didn't round anything. That just was
Gotcha.
19.4.
why the GPA
So when you put 3.5 in, you get 25.15.
Oh, you're so
okay.
So I wouldn't round.
You see words?
That makes sense.
Because also you got 1.55, right? Oh,
That's how you teach math. We teach you how to
wait, well,
Okay, like George.
yeah, but
we teach you.
I don't know if my answer is right. So,
What for you?
No. All right. Quiet down, please. So GPA of 3.5 has a predicted ACT of 25.15, which means we have a residual of 1.85. What is the predicted ACT score for the kid of 3.1? 20.55, which is also this one down here, because we have another 3.1 GPA. So what's the residual there? 22 minus that would be what? 1.45? And then 19 minus that would be negative 1.55. What's the predicted ACT score for the student with a 4 point? 30.9, and they've really got a 31, so 31 minus that would be 0.1. And then the predicted ACT score for the 3.7 kid? 27 point what? I'm sorry. Thank you. So then 26 minus that would give us negative 1.45. All right, so with residuals, we make a thing called a residual plot. And we're going to do it by hand, and then of course I'm going to show you how to do it on the calculator. With 6 pieces of data, it's not hard to do by hand. If you have more data, the calculator is helpful. So with the residual plot, you're going to make your y-axis And then your x-axis is always going to go right through the center. It should always look like that. And I apologize for the extra lines the copy machine loves to put on there. Now, the residuals are gonna be on the Y. So we have 1.85 is our biggest and negative 1.55 is the smallest. So I'm going to go from positive 2, that's 0, to negative 2. And since we're making it by hand, of course, it's going to be estimated. It's not going to be perfect. I'm going to put my little halves on there to help me out a little. And then your x is your x. So x is still GPA, which I'm going to, because I have that there, I'm going to put, this is my x and x is GPA. I'm going to put it off to the side. So GPA, we have 4.0, that's 0, so 2 is in the middle, 1, 3. I like how my x-axis is rounded too, sorry. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to take my GPAs, which are these numbers here, and I'm going to plot them with my residuals. So this kid had a GPA of 3.0 and a residual of negative 0.4. So 3.0 is right here and negative 0.5 is right there. So unfortunately it's like right in the middle of my label for the 3. Then I had GPA of 3.5 with a residual of 1.85. So that's pretty close to 2 up there. Like I said, since it's by hand, we're estimating, so do the best you can. 3.1, 1.45. So around there-ish. 4.0, 0.1, so just barely off the x-axis for that one. 3.7 and a negative 1.45, so that's 5, 6, 7, around there. And then 3.1 with a negative 1.55. Notice how on my residual plot, I had 6 pieces of data. 3 of them are above the x-axis, 3 of them are below. Residual plots should have about an equal amount of data above the x-axis and below. I'm sorry, say that again? On the 3. And then the third one above is right there. The other thing about residual plots, if your data has a linear relationship, the residual plot should have no pattern. If your residual plot has a pattern, that is a bad thing. That tells you your data is probably not linear. So residual plots should have no pattern. And residual plots should about equally, I mean, if you have an odd amount of data, you're not going to have an equal amount above and below. But it should about equally split the amount of points above and below. Data should be evenly split. Am I on the screen or off the screen? Except for my hands in the way, huh? it says above. Should be evenly split above and below. All my letters ran into each other. I honestly was looking at the clock when I wrote that because I wanted to see how much time was left. Alright, so now I'm going to show you how to do it on the graphing calculator. Are we alright? I did write out the steps, at least what I thought made sense. These are the calculator steps. Calculator. So you should have the data in there already. If you don't, maybe just listen. So we have our data in there, right? I have my GPA in list 1, ACT in list 2. So the first thing we want to do, excuse me, is go to y equals, and we're going to type in our least squared regression line. So if you go to y equals, my y1 has some stuff in there because I let my 2-year-old play with my calculator. If you have anything in there, clear it out. Just highlight it and hit clear. Once it's clear, we're going to type this in there. So we have negative 15.1 plus 11.5x. Now the x you have to use is the button right next to alpha. So alpha is right below second, and then to the right is the xt theta n. Use that button to get x. Right next to alpha, in between alpha and stat. Are we good? Now that we have our least squared regression line in there, we're going to go into our lists and we're going to define our lists like I showed you the other day. So quit out of there. Go to stat. And we're going to edit. So we're going to define list 3. So when you define list 3, remember you have to highlight L3. Otherwise, it's going to tell you it's an error. So L3 has to be highlighted. And what we're going to do is we're going to get all our predicted ACT scores. So we're going to tell the calculator to take our least squared regression line, which we put in Y1, and we're going to tell it to use list 1 for the X's. And then it's going to give us all our predicted. So to get to Y1, you're going to hit bars, not second bars, just bars. Should take you to this menu. You're going to go over and highlight Y bars. We're working in a function, so hit enter, and it should take you to the list of all the Y equals. So I put my equation in Y1, so I'm going to hit enter. And notice right now I have list 3 equals Y1. And then I'm going to put parentheses list 1. And that tells the calculator to take all these values from list 1, plug them in for X in my regression equation. When I hit enter, notice it gave me all those predicted ACT scores. Are we good so far?
Yeah. No, absolutely. Just you hit this, so like to there, and then hit and then you highlight the list, then you hit bars. Oh? Did you put in parentheses?
I noticed that was falling off. I don't
Can we
remember.
run that back? Can we retry that?
Yeah, how do we set up the regression equation?
You just type it into Y equals. See, Hayden, when I'm going, hey, are we good? And you're not saying anything.
I hope so.
Okay? But since I'm running out of time, I'm going to move on, and you guys that have questions can hang out for a minute. So in my list, I defined list 3 to plug the x's into my regression equation, so now I have all my predicted y values, my predicted ACTs. Then I need to find my residuals. My residuals are the actual ACT data minus the predicted. I have my actual ACT data in list 2. I have my predicted in list 3. So I'm going to go up to list 4, and I'm going to tell it to take list 2 minus list 3. Actual ACT minus predicted ACT. Make sure L4 is what you have highlighted, not the first entry box. Then it gives me all my residuals that we just went through and found by hand.
It gave me 16.
Hold on. I'll be
List
back.
1 minus list 2.
List 2 minus list 3. It's all typed down here. And then, now that I have my residuals, I'm going to use a graph to make my residual plot. So I'm going to go into second y equals to get my stat plot. Go into plot 1. We want a scatter plot, which is that first graph. Now, remember I told you our x is still GPA, which is in list 1 for me. And then our y is going to be our residuals, which is list 4. So I'm going to have list 1 and list 4. When I hit graph, I don't get anything, so I hit zoom 9. Didn't do it. Zoom 9. There we go. And there is my residual plot. Now, the calculator zoomed in. It's only looking between a little below 3 and a little above 4. But I have my 2 dots above, the one right on top of the x-axis, right below, and the 2 below. So I have the same residual plot. The calculator just zoomed in a little more. Questions?
Are we supposed to remember all of that?
Yeah.
How did you get list 3?
Why would I be joking?
Yeah, my list 3 says data error.
Okay, hold on. So, in your homework, I did not get to talk about S or R squared. So if you see a question in your homework that says anything about S or R squared, skip it for now, okay? I think there's only a couple, and I think it's mainly about S, and I'll just get to that next time.